In a world where the distant future features robots taking center stage, they've long been envisioned as reliable and charming companions. Yet, the technology has remained elusive, confined to the realm of science fiction. Enter RT-2, an extraordinary AI that bridges the gap between human instructions, digital comprehension, and seamless robotic execution, creating a truly futuristic experience where your commands bring your surroundings to life. RT-2, short for Robotics Transformer 2, serves as a Vision Language Action Model, VLA. This advanced AI model has the capability to understand both text and images obtained from the internet and translate them into robotic actions. Traditionally, robots relied on intricate systems, involving separate high-level reasoning and low-level manipulation components, which often resulted in a flawed communication process to execute robot movements. Think of it as having to think about what you want to do and then having to relay those instructions to the various parts of your body for movement. However, RT-2 simplifies this process by integrating both reasoning and action generation within a single model. This means it can handle complex reasoning tasks, similar to foundation models, while also producing specific robot actions. One of the remarkable findings of RT-2 is its ability to transfer knowledge from its language and vision training data to guide robot actions, even for tasks it has never specifically been trained on. Notably, this knowledge transfer can occur with just a small amount of robot training data. Humans have an innate ability to acquire knowledge from diverse sources such as books, videos, and personal experiences. They can then effectively utilize this knowledge in novel situations. For example, when presented with a plate full of fruits on a table, humans instinctively understand its characteristics and how to handle it without needing explicit instruction for every aspect. On the other hand, robots usually depend on precise data for their tasks, requiring information about their surroundings and the specific actions they are expected to carry out. Even minor alterations in the environment can lead to malfunctioning in their operations. For example, if you wanted previous systems to be able to throw away a piece of trash, you would have to explicitly train them to be able to identify trash, as well as pick it up and throw it away. RT-2's significance lies in its vital role as a breakthrough that narrows the learning gap between humans and robots. It utilizes transformers, an AI model that learns from extensive internet content, similar to GPT-3's text generation on diverse subjects. RT-2 goes beyond merely processing text or images, it can translate them into actionable instructions for robots. All you need to do is provide straightforward commands to the robot, and it will comprehend and execute the task accordingly. The RT-2 system comprises two primary components, a Vision Language Model, VLM, and a Vision Language Action Model, VLA. The VLM gains knowledge from text and web images, grasping concepts like object recognition and their relationships. On the other hand, the VLA, an enhanced VLM, not only learns but also has the capability to direct robotic actions. The previous model, RT-1, was limited to familiar tasks it had encountered and could perform basic functions such as item pickup. However, the newer model, RT-2, has surpassed RT-1 by incorporating web data into its learning process. This enhancement enables RT-2 to undertake a wider range of tasks and effectively deal with novel situations. By leveraging web information, RT-2 adopts a human-like learning approach, capitalizing on the extensive online knowledge while avoiding the distractions humans might face, such as getting sidetracked by endless Wikipedia links or spending hours watching cat videos. The VLM section of RT-2 is trained using abundant online text and images, such as content from Wikipedia articles and news reports. It transforms this material into unique formats known as embeddings, which effectively encapsulate the underlying meaning of the text or image. These embeddings can subsequently be converted back into their original form, whether it be text or images. As for the VLA part of RT-2, it also utilizes online data, but it incorporates additional information gathered by the robot itself. This includes images captured by the robot's sensors, commands issued by human operators, and the robot's corresponding actions in response to those commands. Similar to the VLM, the VLA also transforms the input into embeddings. However, it goes a step further by converting these embeddings into robot actions, represented as special action words. These action words detail the robot's capabilities, such as movement or grasping, and include specific instructions like direction and speed. For example, the phrase "move left 0.5" instructs the robot to move half a meter to the left. The VLA's functionality relies on the application of VLM transformation, a method that enables the VLM to anticipate robot actions rather than being limited to processing text or images. This approach initiates with a clean slate for action prediction but heavily capitalizes on the knowledge derived from online data. Consequently, it can perform tasks beyond its direct training, like tidying up a room, leveraging its comprehension gained from online sources even if not explicitly programmed for robot training. Google demonstrated that RT-2 has multiple capabilities. These include efficiently sorting different types of trash, such as food wrappers, banana skins, and paper cups, and placing them in appropriate bins. However, it is worth noting that it might also pass judgments on your dietary preferences. Furthermore, RT-2 handles various trash sizes and shapes adeptly, including crumpled paper and plastic bottles. Additionally, it possesses the ability to distinguish between objects, like apples and tomatoes or dinosaurs and dragons, based on their visual characteristics and names. When prompted to choose between retrieving the red fruit or the extinct animal, it comprehends the request adeptly, showcasing its proficiency in handling tasks involving multiple steps. For example, if tasked with "I just worked out, can you bring me a drink and a snack to recover?" It swiftly finds a water bottle, picks up the water bottle, brings it to him, puts down the water bottle, finds an apple, picks up the apple, and brings it to him. This ability stems from its thoughtful approach to breaking down complex tasks into more manageable steps. RT-2 possesses the ability to handle novel situations by drawing from its online knowledge. This means it can navigate around obstacles, such as chairs, even if it hasn't specifically learned about them online, as long as the action aligns with its existing understanding. For instance, it can respond appropriately when asked to move an apple to 0. Additionally, RT-2 can adapt to varying environments, such as different rooms, and perform tasks spontaneously, like catching a falling bag or cleaning up a spill with a towel. RT-2's capabilities make it highly beneficial for everyday life. The remarkable aspect is that it learns from its actions, constantly improving its abilities and adapting to handle more complex tasks. It's not merely a robot performing tasks, but a machine that learns and evolves with experience. To comprehend the underlying science of RT-2, we must delve into its innovative features. Firstly, RT-2 employs chain-of-thought reasoning, a technique that allows it to break down difficult tasks into smaller, manageable steps and address them sequentially. For example, when asked to move a banana to the sum of 2 plus 1, RT-2 follows this process. It calculates that 2 plus 1 equals 3, then identifies 3 items on a table, like cups, and finally positions the banana near these items. At each step, it utilizes its VLA model to make decisions or seek clarification through questions. For instance, it might ask, "What is 2 plus 1? To find the sum, command skin table to recognize items, and later execute the task by stating "move banana cup 1." This unique approach enables RT-2 to accomplish complex assignments without the need for explicit instructions. In simple terms, RT-2's version of "Where's the banana" resembles Grandma's version of "Where's my glasses," except RT-2 actually succeeds in locating it. Furthermore, RT-2 operates robots using action tokens, which can be understood as straightforward commands. For example, issuing a command like "move left 0.5" instructs a robot to move half a meter to the left. These action tokens are user-friendly, universally applicable to various robots and settings, and compatible with transformer models handling token sequences. By employing action tokens, RT-2 can perform robotic actions based on real-time data. The process involves a VLM transformation, converting a visual language model, VLM, to a visual language action VLA model, enabling the prediction of action tokens. Additionally, RT-2 can convert visual-only tasks into robot actions, eliminating the need for language input. For instance, it can sort items by color. To achieve this, RT-2 utilizes its VLM model to describe the visual input and subsequently employs the VLA model to determine the corresponding action based on that description. In a scenario where RT-2 identifies two apples, one red and one green, it may describe the apples and decide on an action like move red apple left. This capability allows RT-2 to perform a broader range of tasks, even those that do not require language input. RT-2 represents a significant advancement from its predecessor, RT-1, which was limited in performing simple tasks based on prior experience. Unlike other robotic control methods like VC1, relying on vision and language, R3M, using reinforcement learning, and MU, based on meta-learning, RT-2 demonstrates superior performance in language-commanded task tests, scoring 92.3% compared to VC1's 85.6%, R3M's 81.4%, and MU's 79.8%. Moreover, RT-2 exhibits enhanced adaptability and stability, particularly in novel or unfamiliar scenarios. With the escalating worth of the industrial robotics sector, RT-2 could wield substantial economic influence. As per a Grand View research report, the global industrial robotics market was valued at $44.6 billion in 2020, and it is projected to experience a 9.4% compound annual growth rate from 2021 to 2028. As robots and AI become increasingly integrated into our lives, addressing concerns about trust becomes paramount. Will humans ever wholeheartedly rely on robots and AI? Ensuring their absolute safety and non-threatening behavior becomes a fundamental challenge. The key lies in establishing robust guidelines and rules that these machines must unfailingly adhere to. The burden of responsibility on engineers and developers responsible for creating robots and AIs is substantial. They hold a crucial task of ensuring these advancements not only work as intended but also align with our societal values and expectations seamlessly. If you liked this video and want more content, please show your support by liking and subscribing to the channel. Thank you for joining me today, and stay tuned for the next video.